Hello, everyone. I don't know what time it might be by the time you watch this video or by the time it's uploaded on the YouTube platform, but I wanted to take a moment. I want to show you how to solve the problem that the late night geometry problem that a lot of you were interested in. I shared in the previous video, which I'll link down below, of course. And some of you, I noticed immediately in the comments, you were struggling, genuinely struggling. And I wasn't surprised one bit. I wasn't surprised because I knew you didn't have a lot of you who thought you had a certain level, you don't actually have the foundation that is expected, that we expect, for example, from City Tutoring, that we expect of our students at City Tutoring. So this is not a critique of you, by the way. This is just it's a symptom of a broader issue in the United States, here in America, and in other countries too. But I speak primarily of the United States. And I was reminded as I was reading all those comments of students struggling with it. Some of you did very well, by the way, and you did solve it. But others, you didn't know how to begin. And I was thinking of a question that was asked of me many years ago. It was a gentleman, I can't remember his name, but he was originally from Ireland, I believe from the Republic of Ireland. And he says, would you describe yourself as being satisfied or content or whatever word it was that I would care to use with whether there are sufficient resources into colleges and engineering, math departments. And I said, I think what you have in mind, and I said this years ago, and I still stand by today. It's actually gotten worse. I think what you have in mind is, am I satisfied with what's happening? Because patently it's not producing the results we want at the moment. We don't have a sufficient number of scientists in the United States. We don't have a sufficient number of mathematicians and engineers who are homegrown, I'm talking about, coming out of the system. And it's not acceptable. And one of the reasons that we have not got enough good science and mathematics is that we don't have a sufficient number. I must say this, I know it's going to hurt your feelings, some of you. I know the honest people will not be hurt, but those of you who like to go through life, sugarcoating things, the fact is that we have not have a sufficient number. We don't have good enough science and mathematics teachers in the schools to get the youngsters up to the required standard for coming into the colleges. And there's a variety of reasons for that. And no, not all high school math teachers are bad. Absolutely not. But there are too many who are not qualified. And in fact, there's a lot of high school math teachers who are actually gym teachers. I mentioned that in my biography. That even happened in my school. Some of you have said that even in your school that has happened. So I'm not surprised. Already when I was an undergraduate many years ago in the math department at Columbia University, I was already noticing this. Most of my classmates, even back then, they were not American; they were foreigners. They were not homegrown. Not that there's anything wrong with foreigners studying mathematics, to much to the contrary. But it is symptomatic of a broader issue that is happening here in the United States. So the other thing I wanted to mention, by the way, and I have his permission, very kind young man solved the problem. He actually made a video and he mentioned the City Tutoring geometry problem. Thank you, sir. I don't know what country you're from. I couldn't make out I know it sounded Eastern European to me, but I couldn't, I didn't want to, I don't like to play guessing games. So I will link with his permission. I'm linking the video below in case you want to see a young man solving the problem in his own way, different way, legit way. And I will get to solving the problem. So let's see. All right, so this was the question that we were asking in the previous video. And I'm going to show you the figure in a moment. It says in the figure above, DE, and I'm trying to put that line, it should say line segment. Line segment DE is parallel to line segment AC. DE is equal to 3. The U represents units because it could be centimeters, inches, it doesn't really matter. And for this particular problem. So 3 units. BE is 3 units. BS is 5 units. And then it says find AC if Q, R, S, and T are points of tangency. And I put the multiple choice here: 6, 7.5, 8, 10, or 12. Some of you said 10. Some of you said 8. The most common responses were 10, 8, and 7.5. So let's see who is correct. First thing you got to take into account, I did a little diagram here for you. This was a bigger diagram. And first, whenever you are dealing with a geometry problem, you should always either, if in this case, I was generous enough to draw a bigger picture, but drawing, and I say this as a very bad artist myself, drawing often helps, of course. And so notice what happens here. All right, so we have line segment. I'm going by the problem here. So BE is 3 units. So we've labeled that. And line segment, and I'll get to why I put 5 here. We're going to break it down even more. But where was it here? BS is also 5U. All right, and BE is 3 units. So we're going to figure out how to label things properly. The first thing to note, so we said that the segment here is worth 5, right? BS is 5 units. Now, if we take into consideration a few things, we need to direct our minds. We have an inscribed circle, we have a circumference before us. And more importantly, let's look at point B. If you observe carefully, when you connect an external point to our point of tangency, something remarkable happens: equality. And I'm not talking about the artificial kind of equality that's imposed by bureaucrats or shady politicians, but I'm talking about a true, rigorous, unshakable equality that is dictated by the tangent segment theorem. It's a venerable theorem, it's been unchallenged for centuries, and it decrees that if two tangent lines are drawn from a single external point to a circle, then those line segments are congruent. That is, equal in length. So there's no exceptions to this. The order prevails. And so we have a single point outside the exterior here. And notice what happens. B, we said that in the problem, let's look at the problem again. We're saying Q, R, S, and T are points of tangency. So line segment BS is 5 units. That means that we know that. What about line segment BQ then? We already know that BE is 3. We want to make that equal. We'll make that 5. So why not make EQ, I'll use a different color here. Why not make this EQ worth 2 units? And that way we get equals here. So far, so good. Now, the next thing to take into consideration. All right, now notice that point E, which is exterior to the circumference, connects to point T, which is, according to the dictates of the problem, a point of tangency, and also connects to point Q. So that means that these two segments are also equal. And that means that if EQ is 2 units, ET is also 2 units. And let's see if I can use a different color. I'm running out of colors here. So this right here is 2 units. Now, the problem also tells us, let's go back to the problem. It tells us that DE is equal to 3 units. We already know that a part of the segment is 2 units by this law, by this congruence. So that means that the smaller segment here, or the other remaining segment, dt, is going to be 1 unit to make the total. So this dt here is going to be 1. Now, normally I draw little, those lines in there, but I don't have room and I don't want to make a mess. Now, we also have an exterior point to the circumference. And that exterior point joins, as you can see here, with S, which is also, let's double check, the problem tells us that it's also as a point of tangency. Likewise with T, also a point of tangency. So the length of those two segments are equal, actually. So that means that if dt, we said, equals 1, ds is equal to 1 as well. We're going places with this, aren't we? Next consideration. Now, I want you to consider that we said that the entire SB was equal to 5. That means that you should also take into account that DB is going to be 4 units. I'm not going to write it just now, but just keep that in mind. Now, in the upper triangle, right, notice you have 2 sides that are of equal length. That means you are in the presence of an isosceles triangle. This means we also have 2 equal angles. 2 equal angles. Which ones? Opposite angles to the sides will be equal. So, which angle is opposite BE? Well, D. So I'm going to use, let's see if I can use green perhaps to indicate that. So this angle right here, we can shade it in as equal. And what about opposite to DE? Well, your only choice is B. And therefore we shade it in, we use green here, just to indicate that. Now, we look at the problem again. In the figure, it says, in the figure above, DE is parallel to AC. Well, that means that angle A on the bottom here is also equal. So why not shade it in? If you don't know these properties, maybe you should consider taking geometry here at City Tutoring. We offer geometry as well. Rigorous geometry, not the watered down nonsense in the schools, in the public schools. All right, now, so later on, as we move on, we can assign values to those angles, right? We can say alpha, beta, theta. Oftentimes in mathematics, we use the Greek letters. Now, we notice also visually, notice that triangle ABC is also an isosceles triangle, isn't it? So the problem is asking us, where was it here? Find AC. Find AC. So we're going to assign a value to AC of X. And let's see if I can use a different color. I'll just use blue. In case I don't think I have used blue before. Let me see if I can choose something else then. Well, we'll try pink. Why not? So this whole thing, right, on the bottom, is going to be X. That's the unknown. All right, the next thing to consider. Now, if we look again at the smaller isosceles triangle, if you draw a height from the vertex, in this case you have the vertex, let's say E, and if you have something called the median, and a median is a line that connects the vertex to the midpoint of the opposite side. So in this case, if I draw a little height from E in this direction, little angle here, we've created a situation here. Notice that we said earlier that if SB was 5, if SD was 1, right, that means that DB, the whole thing, was 4. But now that we've traced this line, we have 2 units. We break it up into 2 units here on each part. So far, so good? All right, now, the next thing to consider is what happens when you inscribe a circumference inside an isosceles triangle. Well, typically, that means that if you know a little bit about geometry, you know that the circle is going to be tangent to all 3 sides of the triangle. And its center, by the way, it's called the incenter, and it's the intersection of the angle bisectors of the triangle. So that means that the circle's radius is going to be the distance from the incenter to each of the sides of the triangle. It means the triangle sides will be tangent to the circle at the points where the angle bisectors meet the sides. And of course, the incenter is equidistant from all 3 sides of the triangle, right? So kind of like if I were to draw that height here from C to S, and hopefully comes out neat. I'm going to use a darker green. It's not going to be perfect, but you get the point. So what do you have here? Now you've got, well, we could create an angle right here, just in case. And now we can proceed to assign values to our angles. Now, earlier we talked about assigning values to the angles, right? So here we have B, D, and A that we shaded in earlier. So we can call those, since they're equal, we could call them alpha. So that means that B is alpha, D is alpha, and A is alpha. Now, once we have this information, why not use the trigonometric ratios that we know about? We know that, for example, in the case of the smaller triangle on the top, which I'm going to shade it in, see if it lets me do it, this right here, I've already got my, I can use cosine here. The cosine of alpha would be, it's adjacent over hypotenuse. The adjacent angle here is 2, and the hypotenuse, as you can see, is 3. So the cosine of alpha is 2/3. Now, in the bigger triangle, since it's an isosceles as well, that means that we're looking for AC on the bottom here, and that means AC has to be equal to BC, right? So this whole line segment here, we can also call it X, and proceed as follows. Now, notice what happens. We've got a big, another triangle here that we can use. Let me see if I can shade it in a different color. We can use that. Or perhaps, there we go. Notice what's going to happen here. This whole triangle the bigger triangle, that is, we can use the trigonometric ratios here, because again, the trigonometric ratios are adjacent over hypotenuse. So in the case of alpha, well, we know it's going to be the adjacent is going to be 5, right? Because that's 3 and the 2 there. And of course, we're looking for x. So the cosine of alpha in that case is 5 over x. So far, so good. Now, and we had said that the alphas here are equal, right? So we have everything we need now, finally, to solve this problem. We then set them equal to each other. We're going to create a proportion. We have 2/3 equals 5 over x. When you're solving proportions, you cross multiply. 2 times x is 2x, obviously. 3 times 5 is 15. We now have to solve for x, the missing value, divide on both sides by 2. 15 over 2 gives us a final answer of 7.5 units. So those of you who said 7.5, congratulations, you are correct. And hopefully this video was informative. If you did not get 7.5, now hopefully you see why the correct answer was 7.5. Thank you all. Please continue to bless this channel. Please continue to support this channel. I'm really, really blessed by having you all here and by your support. And you've seen the proof. I'm going to continue to churn out these math videos every single week. I'm working for you. I'm working for you. So I ask that you please, if you do like the content of this channel and you agree with the vision that we have, please subscribe. You can hit the like button. You can share with other people, and I'll be sharing in the pinned comment the link to the video of the foreign student who was able to solve the problem. Thank you all, and God bless, and have a good night. By the way.